Alright guys, welcome to the notes on 4.5. We're going to look at scatter plots and lines of fit. Okay, scatter plots are just plotting data. You guys have done a lot of this before. We're just going to take it to a whole nother level. So that's what we do around here. We take things to a new level. Alright, data with two variables are called bivariate data. Bi meaning two, variate meaning variable. Not very complicated there. A scatter plot shows the relationship between a set of data with two variables, and we graph them like ordered pairs or ordered players. Ordered pairs on a coordinate plane. Scatter plots are used to investigate a relationship between two quantities. So you can notice right here we have this set of data. You can see how it's kind of like trending upwards. We refer to that as having a positive correlation. Here you can see this bit of data is like trending downwards, not in a line, but just trending that way. It's getting less and less. So that has a negative correlation. Here this has no correlation. This is just all over the place. There's nothing really, like you wouldn't be able to come up with a conclusion other than that data doesn't have a direct relationship. So the first thing we need to be able to do is just to look at a set of data and determine, does it have a relationship? And if so, is it positive or negative? And then describe the meaning in it. So for example, here on this, this graph shows a positive correlation. As the number of hours worked increase, the wages usually increase. It's just as simple as that. It's being able to look at a plot, at a scatter plot, and be able to determine some sort of conclusion based on that. Refer to the graph on international travel. So international travel, that's up here. So this graph up here. If we look at that one, okay, positive, negative, or no correlation, and then what does it mean? So let's go back up here and look at that one. Positive, negative, and what does it mean? Well, what do you guys think? I agree. It's going up. Okay, it's going up, and then so it has a positive correlation, and then what's going up exactly? And so over here we have travelers in the thousands, and over here we have the years, and so basically what's going up is that the number of people who traveled internationally has increased steadily over the last 30 years. That's pretty much all you got to say. That's all you got to say there. All we're looking for, what the relationship is, and then some sort of descriptor. So lines of fit, a scatter plot can show whether there is a trend in a set of data. When the data points all lie close to a line, we can have a line of fit, also sometimes called a trend line, to model that data. So here's the steps. Step one, and this is where, if you were the note-taking type, you might write these down. So step one is you're going to make the scatter plot and determine whether any relationship exists. If there is a relationship, you're going to go to step two. You're going to draw a line that seems to pass close to most of the data points. This is a line of fit. It's an estimation. It's not going to be a perfect line, okay? So we're going to draw a line that looks kind of close. It's an estimate. Step three, we're going to use 2 points on the line. That's a big key right there. 2 points from the line. Not 2 points from the data necessarily, but 2 points from the line to come up with an equation for that line. And then step four, we're going to use that line to make predictions. This is the kind of stuff where students ask about, when am I ever going to use this? This kind of stuff is used in real life, in real jobs, all the time, everywhere. Okay. So for example, step one, with this set right here with roller coasters, largest vertical drops of 9 roller coasters in the United States after 1988. And then we're going to look at identify the independent and dependent variables. We're going to make the scatter plot. We're going to predict the vertical drop in a roller coaster built 30 years after 1988. Okay, so that's coming up. So we better get to work. So here's years since 1988, and then the vertical drop in feet, and we can see that this data is trending up. Okay, so step one, we make the scatter plot and we determine that it's trending up. Step two, draw the line of best fit. This is where we have to understand that the line isn't necessarily going to go through all the points. It's going to be an estimate. I could do this and you could do this and we could get 2 totally different lines because the line is an estimate. All right. So we draw that line. Then we're going to pick a couple points. Okay. You're going to pick a couple points from the line, not from the data. So the points that the example picked were 2 and 150. So that's about right there. And then 12 and 300, which is about right there, and we use those to find the slope, and then we use point slope form to find the equation of the line, and there it is. Okay, so there's the equation of that line. This problem continues on the next page. Then, yikes, hold on, cool your jets. Okay, then what we do down here in step 4, a slope of 15 means that the vertical drop increased an average of 15 feet per year, and we started at 120. And so then all you have to do to find 30 years after 88 is substitute it in, and so supposedly in 2018 there's going to be a roller coaster that has a 570-foot drop. In class, we should look up what the current leader is, because this book is not brand spanking new, so we can look it up and see what the current drop is. Okay. All right. So if we were to do this on our own, this is what we would have to do. So the table shows the dollar value in millions for the sales of CDs for the year. CDs. I don't even know that you guys know what those are. So if you don't, we'll talk about that in class, because there's a chance you don't. So make a scatter plot and determine what relationship exists, if any. So all I want you to do right now for number 2 is just make the scatter plot and determine if a relationship exists. Okay? So you're going to sketch this out. We're going to have the year down here, and we're going to have sales over here. And the year, you could just put, this could be 0 as in 2000, and so you could just go 1, 2, 3, 4, 5, 6, 7, 8. And then the sales, let's see, we start at 13,000, we go down to 5,000, so we could just do this in thousands: 13, 12, 11, 10, 9, 8. And mine isn't going to be long enough, so you'll make yours longer and better, and it'll be great. And then I'm not going to do all this one because you guys have done this a bunch of times. So in the year 2000, we were at about a little above 13,000. So let's put that all the way up here. 2001, right around 13,000. So that's here, 12,900. 2002 was right around 12,000. So you keep making these points, and then we're just going to see, is there a relationship that exists? And hopefully you're going to make yours. You'll see the scatter plot, and you'll determine that, yes, there is a negative correlation here. Okay, there's a negative correlation. It's going down pretty steadily. Okay, not constantly, because it's not a line, but pretty steadily. In lesson 4.2, we learned that linear extrapolation is used to predict values outside of the range of data. Okay, you can also use linear equations to predict values inside the range of data. This is called linear interpolation. Okay, so this is just, we're going to predict an exact data amount within the data that's given. So here we have a scatter plot, and we're going to find the approximate number of United States travelers to international countries in 1996. All right, so the data here goes from 0 to 2010. So what we're going to do is we're going to use a line of fit, and we're going to come up with 2 points. We're going to find the slope. We're going to use the slope in one of the points to find the equation of the line, and that's what we have here. Then all we're going to do is plug in here. 1996 is year 6 in this graph, so we plug 6 in, and we find the exact amount, or not the exact amount, then an estimate of that amount. So there were approximately 50,933,000, because it was done in thousands, so 50 million, almost 51 million, who traveled from the U.S. into international countries. Pretty easy. Okay. Use the equation for the line of fit for the data in guided practice 2 to estimate CD sales in 2015. So you're going to go back to this graph for those of you that didn't make it. You're going to need to finish making it. And then we're going to take 2 of those points, and we're going to come up with a line of fit. So what I want you to do is I want you to try this on your own. Okay. I want you to come up with, you need 2 points from that line, and come up with what's your equation. And then using that equation, you're going to have to estimate the sales in 2015. Okay? I am not going to give you the answer to this right now. I'm going to ask that you guys actually do this, and then we will talk about our answers and how different they are, because if I give you an answer, you could be right and not have the same answer, because these are all estimates. So we're going to talk about this one in class. And that's it. Okay, once you do that, I would like for you to try the check your understanding 1 and 2, and then we'll do number 3, 8, all those 5 parts. We'll do that one together. I really just want you to make sure you can do 1 and 2. Describe the meaning. That's the important part. Can you guys see that these are positive? Of course you can, because you're smart kids. But I need you to describe the situation so I know you know what that means. Make sure you have an answer for the example on the previous page, and then we'll do number 3 together to make sure everyone is on the same figurative page. All right? See you next time. Bye.